Hello friends. So right now we are going to study about position time graph, and in this case I will be covering all the possible position time graphs, okay, in each quadrant. So at first let's see, if the position time graph is given like this, okay, if it is increasing in any quadrant, okay, if it is like this, then we can say the velocity is positive, okay. In this case velocity is positive. Speed is always positive, but velocity may be positive or negative, but for this case velocity is positive. Now let's see how velocity is positive. So for that you have to find out slope of the graph. If you don't know the slope, let's see, I will clear that concept also. Slope of the graph. So how can we find the slope? So first step to find out the slope is to take any 2 points in a given line, okay. In the graph you have to take any 2 points like these 2 points. Now make a triangle, right angle triangle, by taking these 2 points. Like if this is point A, this is point B, and this is point C. So this is a triangle, and if this angle is theta, then tan of this angle, tan theta, is called slope of the graph. Okay, so you can find out slope of any graph. It's not like that the position time graph is the slope of the position time graph is found with the help of this method. You can find out any kind of slope with the help of this formula. Okay, so tan theta gives the information about slope, and for specific position time graph, if you are finding out the slope, we will get information about velocity. How its velocity? Let's see. See, if we find out tan theta is length of opposite side upon adjacent side. This opposite side gives information about, see, this is x, so this will give information about delta x, and this is parallel to time axis, therefore this will give information about delta t. So tan theta is equal to slope is equal to velocity. See, in this case delta x is positive, delta t is also positive, so therefore we are getting positive velocity. So for this case velocity is a positive. Same goes for this case also, irrespective of the quadrant, even if it is in even if the x is negative, but from going from point A dash to point B dash, see, it is moving towards positive x-axis. Okay, so for this case also velocity is positive, for this case also velocity is positive, for this case also velocity is positive. So if you are trying any MCQ or a numerical, if you see x versus t graph is like this, then always velocity will be positive. Okay, now let's see this graph where velocities are negative. Velocity is negative for all these cases irrespective of the quadrant. So let's see how it is negative. So again we have to deal with the slope. Let's find out the slope of this graph. We can take any one of the graph. So let's take these 2 points, point A and point B. Okay, so point A is the position when time is t1. Okay, this is position. Now later on, see, when it comes to time t2, at that time the position is moving towards negative x-axis. The object is moving towards negative x-axis. As a result, the tan theta, which is the length of opposite side upon adjacent side, this opposite side will be negative. Why? Because while moving from t1 to t2, when the time is increasing, the position is moving towards the origin, or we can say it is moving towards negative x-axis. Okay, so therefore tan theta will be slope. Slope gives velocity, but in this case velocity is negative. So if you see such type of graph in your exam, then always take velocity to be negative. Now let's see another one. I said I will cover each and every type of graph. So let's see, if the graph of x versus t is given like this. This is very confusing, but I will make it easy for you. So if the graph of x versus t is like this, it means that the velocity is not constant. See, in this case the velocity was constant. The velocity in this case was constant. How it's constant? Because if you find out slope at this point or you find out slope at this point, for all these points the angle theta remains same. Theta are not changing. Here also, if you find out tan theta at this point or tan theta at this point, or you take a very large tan theta or very large triangle, even though you will get the same angle theta. But in this case, the theta is not constant everywhere. Theta is constantly changing. So if you see theta at this point, if you make a slope for these 2 points, then this theta will be like, if this is theta and if this is theta dash, then you can see that theta is greater and theta dash is small. It means the magnitude of velocity is decreasing. See, tan theta gives information about slope. Okay, and that slope for x versus t graph is nothing but velocity. So therefore, in this case, velocity, magnitude of velocity is decreasing. Okay, now let's see this case. Here the slope is like this. The slope is greater one. After some time the slope is decreasing. So we can say here the magnitude of velocity, again it is decreasing. Why? Because initially slope was greater, but later on the slope decreased. Okay, again for this graph, let's see. Initially slope is theta, later on the slope increased. As the slope is increasing, we can say magnitude of velocity is increasing. Why? Because with the increase in slope, the magnitude of velocity will increase. Now let's see this graph. Initially the slope is very less, later on the slope becomes larger one. So we can say magnitude of velocity is increasing. See, I have not mentioned directions here. Let's in order to solve such questions, at first we have to deal with magnitude. So in this case, magnitude of velocity increases, decreases, decreases, again it is increasing. Now let's see the direction. Let's see the direction. In which direction it is moving? See, it is moving towards negative x. See, this is called positive x, this is negative x. So as the time is moving on, the x is becoming negative. So direction is negative, is negative. In this case, direction, see, initially it was here, something, let this be x. Now as the time passes, it is moving towards positive x axis. Therefore we can say direction is positive. In this case, see, direction, see, as the time passes, it is moving towards negative x axis. See, as the time is increasing, it is moving towards negative x. Therefore in this case, direction is again negative. In this case, it is moving towards plus x direction. Therefore direction is positive. Now the case for which magnitude of velocity is decreasing, for that acceleration will be negative. Decreasing, again it is negative. Decrease means negative, increase means positive. Let's take it that way. It is increasing, therefore this is positive. Now in lower standards you have studied that negative becomes a positive, positive negative becomes negative. So similarly here also you can see this is negative, this again is negative. 2 negative becomes positive. So for this case, acceleration is positive. For such case, acceleration will be positive. For this case, see, this is positive and negative. Positive negative becomes negative. Therefore acceleration is negative in this case. For this case, see, this is positive, this is negative. Positive negative becomes negative. Therefore acceleration is negative in this case. And for this case, see, this is positive positive. Therefore acceleration is positive. I hope it is clear. Try this one with the same method. Okay, and tell me in the comment section how you have solved. The hint is right over here. You can pause the video and try it yourself. I am eager to give the answer. Pause the video for a second. Seconds, I think, or a minute or two. Now let's see the answer. See, in this case, if you want to solve this thing, see, the line is going like this. You can compare this line with any one of these 4 lines. see one of the four lines over here is resembling this one. So if you see this one, this line is exactly like this. Okay, see, as the time increases it is decreasing, so whatever the thing written over here will go for this line. Okay, so for this case again magnitude of velocity will decrease, direction is negative, acceleration is positive. Similarly this line is resembling the line which is over here, so whatever things written over here will go for this also. So if you remember this graph, or if you remember that technique, at first you have to find out the magnitude. How the magnitude is decided? It is decided with the help of slope. Okay, if the slope is increasing, then the magnitude will be positive. If the slope is decreasing, magnitude will be negative. So at first find out the magnitude, and in secondly you have to find out the direction, which direction it is moving. It is moving, if it is moving towards plus x, take it positive. It is moving towards negative, take negative. And then simply by taking positive positive positive, negative positive negative, and negative negative positive, you can have the perfect direction of acceleration. So this was all about x versus t graph for accelerated motion. Now let's see some graphs which are very easy, but I think I should tell you. See, this is a graph for a stationary object. If the object is stationary, or we can say at rest, when the object is at rest, the graph will be like this. See, this graph clearly says that if the position is x at some time t, even after the time changes, position is not changing. So therefore object is at rest. For such case, slope is 0. It can be asked in your exams. Slope will be 0, and these graphs are not possible. Why? Because in this case, see, the position is changing but time is not changing. This is not possible. Everyone cannot be Dr. Strange. Okay, so in this case the time is remaining constant and the position is changing, which is not possible. Okay, so therefore such type of graph is not possible. So if you remember any such graph of x versus t I have not taught, you can tell me in the comment section. Okay, thank you.